All right. So is there any other question from yesterday's lecture? Anyone? Anything that you have to ask? Anything that you are having problems with, or anything? Okay, I'll assume there is no questions. We'll start where we left off. We were discussing a simple pendulum, and we're discussing some of the terms that are used for simple pendulum. We talked about how the simple pendulum works, how the oscillations work. So it was basically based on this principle that energy has to remain conserved. And so we discussed about the time period, which is the time taken for this bob to move from R to R to Q to P, and then P to Q to R. So this whole thing is really implying one oscillation, and the time it takes for that to happen is the time period of the oscillation. Now we were discussing about the amplitude, where the amplitude is really the distance that the bob will move from its mean position to an extreme position. So that's defined as the amplitude of the oscillation. So it is really the maximum distance that the bob moves from its mean position. All right. So it's really the distance that is between, you can say that is between the mean position, mean and extreme positions, right? Mean position and extreme position. So that really just means it is either this distance from Q to R. It could be the distance, actually I have written those up over here. So it could be RQ, this distance, or it could be PQ, any one of those distances. So it really is the distance that the bob moves from its mean position to the extreme position. All right, now in nature, it's something happens where this time period really does not depend on, so time period is independent of the length of the string, and it is not independent, I meant it is dependent. It is independent of the mass, so you can say it is independent of the mass, but it is dependent on the length of the string and the acceleration due to gravity, which really means that if I were to do this experiment with a larger string, then the oscillations would be different compared to the oscillations if I were to do it with the smaller string. So the rate of, or you can say the to complete would be different. Similarly, if you were to perform this experiment on some other planet, for example, or the moon, then the oscillation, speed of oscillation would vary, right? However, the mass, it doesn't matter what mass I attach to this bob. It could be really heavy, it could be 70 kilograms, it could be 200 kilograms, or just 1 kilogram. The speed of oscillation will not be affected, which is really not really intuitive, but that's how it is, right? So it is independent of the mass, but it depends on the acceleration due to gravity, and it depends on the size of this string. Now, suppose that you want to find the time period. There are some steps that you will take. The first step in finding the time period is you'll have this bob, and you will make it oscillate, right? Now it will start oscillating, and you will use your stopwatch, and you will time the oscillations. So the more number of oscillations I time, the more accurate result I'll have, right? So because I'm including more number of oscillations, so I'm really just trying to eliminate or reduce the error in my measurement for time. So for example, it's always better to time more number of oscillations. So let's say you will time, normally it's like 20 number of oscillations.
Sir?
Yeah. Hello? Yeah.
Sir?
Yes, I can hear you.
We measure 20 oscillations rather than one oscillation because it gives us more accurate answers and it decreases the errors. That is right?
Yeah, so it really decreases the error in the time period, the time that you're measuring.
Sir, this is experiment. This is practical.
Yeah, it's practical.
Okay.
In what sense really do you mean that?
I
Hello?
performed this experiment in my previous exams.
Yeah. Yeah, you can perform this experiment as well. And this is just to understand basically how do you find the time period? How can you measure time really, right? So
Yes.
you time you time number of oscillations, more number of oscillations, the more the number, the better it is. The result is better. Then you repeat this thing. So for example, I 20 oscillations happen. I timed them, and let's just suppose that 20 oscillations happened in 5 seconds. So when you first timed them, this was the first try, right? So first attempt or first try, you got 5 seconds. You do the same thing again, and now you're again doing this to reduce the errors. You will do another try, and you start the system, you start the oscillations, and the oscillations happen. And let's suppose at this point you get maybe 4.9 seconds, which can obviously happen, right? Because nature is really errors are a common practice for nature. And then you can do it third time, you try it another time, and maybe you get something like 5.2 seconds perhaps, right? So these are different values of times that you're getting, but they're so close. So what you do is you do as many tries as you can, and then you calculate the average. So we can say that you repeat, let's call it first step. And then when you do that, you calculate the average value, compute the average of your results. So how do you do that? You take 5 plus 4.9 plus 5.2, right? And then you divide it by these total number of tries. So you have tried 3 times, so 1, 2, and 3. So you'll just divide it by 3. And whatever the answer that you get, does anyone have a calculator with them? And can tell me, it's 5 plus 4.9 plus 5.2, which is, I guess it's 15.1 divided by 3. So this would be approximately equal to 5, well, really 5.0 something, right? 5.03. So this is the value that you will say that, okay, I'll pick this value and I'll use this value. So this is rather more correct value that you will choose, right? And then of course, this is not the time for one oscillation. So this is not the time period at this point, because remember, this is the time for 20 number of oscillations. So I'll have to divide result by how much? By the number of oscillations, right? By number of oscillations. So once I do that, that means that I'm dividing 5.03 by the total number of oscillations, which will give me the result for one oscillation. So this means that one oscillation really happened in approximately 0.25 seconds. So this 0.25 seconds is the time period for your oscillation, right? So this was just an example. It was just an example that we used these values 5 seconds. It was just one of the examples. But is the idea understood now? How can you compute the time period of your of an oscillation? Really, is that clear? All right, great. So I guess that's more or less that's the end of the chapter. Is there any question that you have in your head at this point that you might want to ask regarding the topic, any topic or the entire chapter?
No, sir. Sir, now please, we want to solve past paper.
Yeah, we will be doing we will definitely be doing past papers. I had this idea that we would do them on Friday, but we'll be solving questions from past papers. Let me see if I have any one of them prepared at this point. Okay, so this one is just a very basic one. So we can do this and then maybe start the next chapter tomorrow. Okay, so this is a very basic topic, and the questions from this topic are also very basic. There will not be all of the questions are not in this file that I just opened. I'll have to prepare another file where I'll include questions from vernier calipers, micrometers, and this simple pendulum as well. So I'll bring those on. I was thinking that I'll prepare them for Friday and we'll work out all the questions on Friday. But let's see what we have over here. All right, so is everyone here?
Yes, sir.
Yes, sir.
All right. Okay, so we'll do them in this way that I'll ask you, what do you think the answer is and why would you think that the answer is this? Anyone can volunteer, and if nobody volunteers, I might just pick any one of you guys and I'll ask them. It doesn't matter if you get the question wrong. That's not the point. The point is, one, to of course build your confidence, because when you're solving these problems, you should be confident about your answer, especially in the MCQs, right? Because if in the MCQs you're not confident, then you are more likely to get the question wrong. Maybe you might have known the correct answer, but you're not confident, you're overthinking, and you can get the question wrong. So let's start with the first question. Which instrument is most easily used to measure the internal diameter of a pipe? We have some options. Manometer, we did not really study it, so you might be thinking that's not the answer, obviously. Measuring cylinder, micrometer, vernier calipers. Anyone have any idea what a manometer is?
No, sir.
Okay, so we'll be discussing that. We could have been discussing that when we'd be studying topics related to fluids, but it's really used to measure the pressure, right? So it's
Yes,
like
sir, I know about it.
yeah, okay, so it's really like a tube, and it really is used to measure the pressure, right? So then you have measuring cylinder. Measuring cylinder is used for
Measure the cylinder.
It's used to measure volumes, right? So it's like it's a cylinder. It's ignore my drawing. Yeah,
In
so you
cylinder,
fill.
we measure volume.
Yeah, exactly. So you measure volume with this, and it's given in centimeter cube. Remember what your question is. It's saying most easily measure the internal diameter of a pipe. Now, there are two options that might make sense to you at this point: micrometer and vernier calipers. Which one should it be?
Some
Of the-
micrometer, I think.
Vernier calipers.
Okay, so we have both answers are here. I would like to know the reasoning behind it. So first, I think you should go micrometer. Why should it be micrometer? Why do you
Because
think? Yeah.
because it is easily measure the diameter of pipe.
Okay. I mean, okay, and so why would it be a vernier caliper?
Because vernier calipers have a set of inside jaws that are used to measure internal diameters.
Yeah, sorry, can you please speak a bit loud? Let me check the volume for
I'm
my
sorry, it
tab
might be
though.
my
Okay.
headphones. I said that
Yeah.
vernier calipers have a set of inside jaws that are specifically used to measure internal diameters of pipes
Yeah,
and
yeah.
cylinders.
Yes, exactly. Because vernier calipers are would be a better option at this point, because they have these jaws. So if you remember, God, I cannot draw a vernier caliper here, but I'm sure that you know what it looks like. It has those specific jaws, and those are we'll use the internal jaws of the vernier caliper to measure diameter of a pipe. Its micrometer would not really make sense at this point, because a vernier caliper is specifically designed to measure internal diameter. So this diameter was really a key word at this point. So you use the internal jaws of the vernier caliper to measure the internal diameter. Is it clear for everyone?
Yes, sir.
Yes.
So they'll give you a diameter with even with a greater or a better accuracy as well. So the correct option at this for this is vernier calipers, right? So is it clear for everyone, or is there any question that you might have?
No, sir.
All right, so let's move to this one, question number 2. It says that the power is measured in watts. Okay, so he's just telling you the units for power. What is the correct symbol for millions of watts? So this is really a play of those prefixes. Now, what do you think would be the answer to this question? You have different options. You have small m with small w, you have capital M with small w, small m with capital W, and capital M with capital W. So any idea what was this used for? What does this prefix denote, or what does this prefix tell you?
This one is for milli, the small m.
Yeah, it's milli, right? And what is milli? It's in you can in I think in factors, all it is 10 raised to power minus 3, right? Which really is 0.001. So that's milli. Now they're talking about millions of watts. So millions is 10 raised to power 6, right? Because what is 1 million? 1 with 3 zeros. So that's 1 million. What is a prefix that is used to demonstrate a number which has 6 zeros in front of it? I'll just say it. It's mega with a capital M, right? So it's mega, and the symbol for that is capital M. Now, at this point, we have this thing figured out that we'll use megawatts. So the symbol is really capital M. But what about the unit for this thing? Watts. It would really be a capital unit, right? Because whenever we define any unit based on a scientist, watts is defined on the scientist whose last name was Watt, right? So if, for example, let me give you an example, Newton. So you write it as capital N. Similarly, watt, it would be used, a capital W would be used. So the correct answer to this is really capital M and capital W, megawatts. These are really very simple questions. Is there any problem with this one?
No, sir.
So it's cool with everyone, right? So it's really very easy, actually.
Yes.
Yeah. Okay, so perfect. So next we have this thing where you have a room measures 4.0 meters cross 3.0 cross 2.0 meters. So these are the dimensions really of the room. The density of the air in the room is also given. And what is the mass of air in the room? So any idea how would we go about this problem? Anyone?
No.
Okay, so I'll just give you a hint that they have given you density. They have given you the dimensions really, right? So these dimensions are, when they say a room measures as this, so these are the dimensions really. So it could be X, Y, and Z. Or you can think in terms of length,
can solve
width,
it.
and height. Yeah, so yeah, sorry, you're saying something?
Sir, I can solve it.
Okay, so how would you go about this problem?
What?
So yeah, so tell me, how would you go about it? How would you compute the mass of the air?
I will done my rough copy. Then I will.
No, of course, okay, that's good. What would be your thinking about this problem? How would you go about it? What would be the first thing that you would do in this at this
Formula.
point?
Formula.
Yeah, so exactly. So we know that density really is defined as the ratio of mass to volume. So how much mass is packed into a specific region of volume, that's density. So hence the formula is simply density is mass by volume. All right, so at this point, we know the density. Mass is asked, so mass is a question. Volume, how can I find the volume of a room? A room may be something like this, right? So how can I, this is really a cube, right? It's a cube, and you can approximate the room to be a cube, and the dimensions are given as 4 meters, 3 meters, and 2 meters. So how do I find the volume of this thing?
So
Maybe
multiply
multiplying
4
them.
multiply
Right, exactly. So I'll just, it's very easy, basically 4 times
24
3.
answer.
Yeah, so you'll get 24. Always remember that these have units, meters, meters, and meters. So we are really multiplying these as well. So meter cube, right? So that's the volume of the room. So volume is also figured out. And the next is very easy. You just have to bring this volume to this side, which will have this density times volume is mass, and the mass would be the density is given. You always make sure that you check that the units are agreeable, right? So the volume, we have computed volume in meters cube, and density at this point, it was also given in meters cube. So we don't have to convert our units at this point. So mass is really density, which is 1.3 kilograms per meter cube times the volume, which is 24 meters cube. So meter cubes cancels with meters cube. And if you do the math, what do you get? Anyone has a calculator with them at this point? It's
31.2.
1.3 times 24.
It's 31.2, the answer.
31.2. All right, 31.2. So 31.2 kilograms. All right. So you can see over here you have some options. 31.2 really doesn't exist, but the closest option to 31.2 is 31 kilograms, right?
Achha.
Yeah. So you can, if there is any question, you were saying something?
No, sir.
Okay. So is this clear?
Yes, sir.
Okay. It's clear for everyone? The approach that we used and why did we do what we did, and well, really everything. Is that clear?
Yes, sir. I clear my
Yes.
all messages.
Okay, perfect.
Yes.
Perfect. All right, so then we can move on to, because this is also a very simple question. A quantity is quoted as having a value of 6.2 ms. In what units is it measured? We have meters, meters per second, microseconds, milliseconds. So anyone in the class who would like to answer this for me?
I think B.
You think B, which is meters per second.
I think it's D. I think
Okay,
it's D.
so it's D. All right, so we have B and we have D. Okay, so the person who said B, why do you think it's B? If you look at the number, it says 6.2 ms. There is no -1 or there is no symbol, a slash between m and s. Meters per second. So meters per second really means m divided by seconds. Meters divided by seconds. Or you can, another way of writing the same thing is as meters and the inverse of seconds, which we write as s minus 1. So is that clear?
Yes, sir.
Okay, for this, God, I keep forgetting
Yes, sir.
the name. Yeah, so is now, do you still think it should be B? Should the answer still be a B?
No,
Do you
sir.
still think that? Right. So yeah. So basically, maybe your confusion was in this thing. How can I write? What does meter per second really means in a mathematical language? So that's what meters per second is. But you see that at this point, it's just ms. Now it cannot be meters as well, because we write meters with M. There is no such thing as if it's 1 meter, then I write 1 M. If it's 2 meters, then I write meters S. It's not like that, right? So it's just 1 meter.